Bismillahirrahmanirrahim. Hello students, welcome to the Electrical Engineering channel. This is the second lecture of the course of electromagnetic theory, and in this lecture I am going to solve some problems related to the vectors, vector products, vector multiplications, and then I will discuss the cylindrical coordinate system, three-dimensional cylindrical coordinate system and its conversion to Cartesian or rectangular coordinate system. So in the first example, I will show you how to check whether the three vectors are coplanar or not. So this is the first vector, this is the second vector, this is the third vector. So to check the coplanar nature of the three vectors, we have to calculate the scalar triple product of the three vectors. And if the scalar triple product is equal to 0, it means the three vectors are coplanar, otherwise they are non-coplanar. So the scalar triple product is calculated by this expression, and we will take the determinant of the matrix, and the first row of the matrix will contain the three components of the first vector. Similarly, these are the three components of the second vector and the three components of the third vector. So we will take the determinant and its answer is equal to 0. It means the three vectors are covalent to each other. Now I will show you how to calculate the volume of the parallelopipe associated with three vectors x, y, and z. So these are the three vectors, and in order to calculate the volume of the parallelopipe, again we have to calculate the determinant, or we have to calculate the scalar triple product of these three vectors, and the value of the scalar triple product is calculated by taking the determinant, and again I will get the answer of 2. So the volume of the parallelopipe associated with these three vectors is equal to 2. So this is also very simple example. In the third example, I will show you how to calculate the scalar projection of one vector along the other and vector projection of one vector along the other. So I have two vectors A and B. So first of all, I have to calculate the projection of A along B. So first of all, I will calculate the unit vector of vector B, and it is equal to the vector B divided by its magnitude, and it is equal to the magnitude of this vector is equal to 5 square plus 2 square plus 2 square, and it is equal to 33 square root, and the unit vector is equal to the vector over its magnitude, so it will be 5 divided by square root 33ax minus 2 by square root 33ay plus 2 by square root 33az. So to calculate the scalar projection of vector A along B, we have to calculate the dot product of vector A with the unit vector of B. So you have both the vectors and just take the dot product by multiplying the associated components, and then add them. So at the end I will get 6 by 33 square root, and this is the scalar projection of A along B. Now vector projection of A along B is equal to A dot AB and multiplied by AB. So if we put a unit vector with this scalar projection of A along B, we will get the vector projection. So A dot AB is equal to 6 by 33, and this is AB unit vector, and after multiplying this value with these components, I will get this new vector, and that is actually the vector projection of A along B. So this is how we can calculate the projection of one vector along the other, or the component of one vector along the other vector. So in this example, I will show you how to calculate the area of the parallelogram. So we have two vectors, and two vectors always make a parallelogram. So the area of this parallelogram can be calculated by taking the cross product and then taking the magnitude of this cross product. So by taking the cross product, we will take the determinant of these two vectors, and the first row will be actually the unit vectors. So at the end we will get this vector which is A cross B, and when we take the magnitude of this vector, we will get the area of the parallelogram. So the area of this parallelogram is equal to 32.17. So this is also very simple example. So this is all about our today's lecture. I hope you have understood and you have enjoyed solving these basic problems related to the vectors. For watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.